UPS Basic Knowledge. UPS Key Parameters. Next, we will learn about the key parameters of the UPS. Firstly, the capacity and output power factor. Usually, we say that we need 200 kilovolt ampere UPS, which means that the UPS capacity is 200 kilovolts ampere. Here, we need to explain the capacity unit kilovolt amperes, which refers to apparent power, compared to another unit, kilowatt, which symbolizes active power. So what does that mean? Active power describes the load's capacity. This power is consumed by the loads and finally turned into heat. There's also reactive power. Technically, the volt-ampere reactive, or VAR. So what's that? Let's use the motor as an example. Inside the motor is a big coil. If the motor needs to rotate, it requires a magnetic field. So, how is a magnetic field generated? The answer is by current. When the current flows through the coil, it generates a magnetic field. In this way, the electric energy turns into magnetic field energy. This is just a transformation of energy and it is not consumed. Therefore, this is called the reactive power. The relationship between these different types of power is that the square of apparent power equals the square of active power plus the square of the reactive power. The output power factor indicates capability of a UPS to carry loads with active power. Generally, the output power factor is 0.7, 0.8, 0.9, or 1. For example, if the capacity of a UPS is 100 kilovolts amperes and its output power factor is 0.9, this means that this UPS has the ability to power a 90 kilowatt load. Therefore, the active power equals apparent power multiplied by a power factor. Efficiency is easier to understand. Inside UPS, a double conversion takes place. So during that conversion, some energy is lost. And from this, we can calculate UPS efficiency. Usually, the efficiency of a medium or large-sized UPS is higher than 0.9. However, we need to remember that efficiency is not constant. It changes according to the UPS load rate. Now, let's talk about the input voltage and frequency range. For this range, the bigger, the better. If the input voltage and frequency range are wide, the UPS can adapt to poor power grids. When the input voltage and frequency exceeds the threshold, the UPS will switch to battery mode. A wide voltage range reduces the battery discharge time and therefore prolongs battery lifespan. When talking about overload capability, we have to understand that a high overload capability ensures power supply quality. If the UPS overloads, it works in normal mode for a short period and then switches to static bypass mode. For this parameter too, bigger is better. A large overload capability means the UPS can work steadily in normal mode and not switch to bypass mode easily, which means that the loads are better protected. Finally, we come to input current harmonic, and this parameter represents the harmonic distortion that the UPS outputs to the power grid. For the power grid, even the UPS is a load, so it will produce a level of pollution that affects the power grid. The smaller this parameter, the better. That's all for this section. Thanks for watching.